All right, so for day 3, we're going to be looking at stretches and compressions, which are a tad bit different than when we looked at absolute values, since we're looking at a different type of graph with quadratics. So make sure you're paying attention and taking slow notes, pausing as needed. So let's take a look first at what happens when we have something like 2x squared. Well, this left side is basically the original graph. What did it look like? Well, when we had 3 squared, we went up 9. When we had 2 squared, we went up 4. 1 squared, or negative 1 squared, 1, etc. So that's what our graph kind of looked like when we graphed it, those points that we had to graph the original quadratic parent function. So what's going to happen when we have something like 2x squared? Well, our first step is going to be to square our number, so squaring negative 3 and then multiplying it by 2. So negative 3 squared is 9 times 2 is 18. And then negative 2 squared is 4 times 2 is 8. Negative 1 squared, 1 times 2 is 2. And then 0 squared times 2 is 0. 1 squared times 2, 2. 8, 18. So take a look at what happened to our coordinates. We still have that same x value, but look at your output. Your output is now twice as much as what it used to be because of this 2 in front, which kind of makes sense, doesn't it? So twice as big. So let's go ahead and graph that. And we're going to put greater. If you want to put double, you can. But it's greater than our parent function. So here's our parent function already graphed. So let's go ahead and graph our points that we had from up here, which were negative 3, 18. Negative 2, 8. Negative 1, 2. And then 0, 0, which right there on that point. So then we're going to go to the other side, and we had 1, 2, and we had 2, 8, and we had 3, 18. And you can see how when it's got the 2 in front, when it's a stretch, it's stretching it and making it skinnier. And it's twice the value that it used to be. So instead of 1, we're at 2. Instead of 4, we're at 8. Instead of 9, we're at 18. So what would this one be? Instead of 16, we'd be at, you guessed it, 32. Be all the way up here. So we could continue that up there if we wanted to. So let's take a look what happens when we have a 1/2 in front. So again, this is just your parent function. We had 9, 4, 1, 0, 1, 4, 9. That's our parent function that we would originally graph. What happens when we have a 1/2 in front? Well, again, we square it first and then we cut it in half. So negative 3 squared is 9, and what's half of 9? Yep, 4.5. Negative 2 squared is 4. Cut that in half. That's 2. Negative 1 squared is 1. Cut that in half. That's half. Put 0.5. 0 is 0. 1 squared is 1. Cut it in half. 0.5. 2 squared 4. Cut it in half. 2. 3 squared 9. Half of 9, 4.5. So we're going to plot these points and see what happens. And you're just going to have to kind of get your guessing hat on for accuracy with those decimals. All right, so for our first one, we want to go to negative 3, 4.5. So negative 3, and then go up 4.5. Negative 2, 2. Negative 1.5. 0, 0. 1.5. Can't really see it very well. And then 2 going up to 2. And then 3 going up to 4.5. Okay, here it is. This is our compression. Yes. So it is less or smaller, which in that case is half, than your values of your parent function, which makes sense because we had a fraction, so we're cutting it down. We're half as much, so we're at a half instead of 1. What's half of 4? Yep, 2. What's half of 8? Yep. Or what's half of 9, excuse me, that's 9, is 4.5. So we just went half as much as we normally would. So we have our compression over here, and we have our stretch over here. So when we graph these, we're going to do 2 together, and then I'm going to have you try 2. We need to keep that in mind that we are doing either, on this first one, 3 times what we normally would. So 0, 0, we're going to go over 1, and instead of up 1, like we normally would, we want to go up 3 times that amount. So what's 3 times 1? Well, 3. So 1, 2, 3. Instead of, when we go over 2, going up 4, we want to go up 3 times that amount. Well, 3 times 4, that's 12. Oh, that's going to go off the graph. So really, we can only graph that one. So going the other direction, -1, we'd go up 3. Over 2, we'd go up 12. And we're real steep here. We're at a stretch of 3 for that one. Let's take a look at number 2 together. We are at, well, negative, so a reflection, but a 1/2, just like we did on the previous page. So we're going to be going upside down for the reflection, but half as much as we normally would. So over 1, just down a half. Over 2, okay, I normally go 4, so half of 4 would be 2. Okay, over 3, instead of 9, I go half that, so 4.5. And then I do the same thing on the other side. Over 1, down a half. Over 2, down 2. Over 3, down 4.5. And now we have our compression. Try 3 and 4 on your own and check when you're ready. So for this one, we should go 1/4 of as much. It's a little trickier on this one because over 1 and up 1/4 is kind of hard to do. So think about going over 2, and we normally would go up 4, but we only going to go up 1/4 of that. And 1/4 of 4 is 1, so it should be over 2 up 1. The other one that's pretty easy is when you go over 4, because you normally go up 16. But 1/4 of 16 is 4, so going over 4 up 4 is another pretty easy one. So at least those 5 points you could get your compression. For number 4, we want to go down because of the negative reflection, and then 2 times as much as we normally would. So we're going to go over 1, down 2, over 2, down 8. So remember, we're going double what we normally would. So we got to keep those perfect squares in mind. If you want to write those perfect squares, kind of 1, 4, 9, 16, and then think about, I'm going to go double. So instead of going down 1, I want to go down 2. Instead of going down 4 on the next one, I want to go down 8, etc. All right, let's take a look at the bottom. Where we have the graphs, we're going to write the vertex and then what's happening with the transformations and then write our function. So the vertex for our one here, it's the red that we're looking at because the blue is over 1 up 1. That's our normal parent function. So we're looking at the red. We went over 1 up 1, 2, 3. So we went up 3 times what we normally did. So keep that in mind. That would be a stretch by a factor of 3. So that's one thing that happened. We're still at 0, 0 for our vertex, so we didn't move left, right, or up or down. So we have an axis of symmetry of x equals 0 going through right there. So the only thing is that stretch by a factor of 3, which means we're going to put a 3 in front. And we should have 3x squared. So for this next one, we're again looking at the red, and we have a vertex of 0, 0. So x equals 0. And it looks like we went over 1, 2, 3 and up 3. Well, 3 normally would put us up at 9. But instead, we're only going up to 3. So we only went up 1/3 of what we normally would. So that means that this is a compression, because we're more wide there, by a factor of 1/3. So we need to have a 1/3 in front of our x squared, and we didn't move left, right, up, or down, so no other transformations that took place. So on this next page, a lot of this is review, and I really want you to practice this on your own. It's kind of putting all the transformations together. We'll do kind of one quick example together, but then I want you to try most of these and practice on your own and then check when you're ready. So vertex is going to be 1, 2, opposite of the inside, keep the outside. Axis of symmetry is x equals 1. And then we are going to graph starting at 1, 2. And we have just our normal, no stretches or compression, so over 1, up 1, over 2, up 4, over 2 this way, up 1, 2, 3, 4, and at least those 5 points to get you there. So it looks like we moved right 1 and up 2. So continue 2 and 3 on your own, and then I will, after we do one of these, pause the video and then check those graphs up there and then the rest of these, what's taking place down here. So number 2 together over here, we have a vertical stretch by 4. We have a shift of 2 units to the left because of this 2 here, opposite thinking. And this 3 is actually a minus. Sorry, that didn't copy well. And so it is a vertical shift 3 units down. So try the rest of this page on your own. Most of this is review of stuff that you've already seen from your other 4.7 days, and then check when you're ready. So here's your graphs from up above, 2 and 3. Vertex, make sure it's upside down since it's a reflection. Make sure you listed all the transformations. Pause if you need a little more time to look those over. And then down here, let's check 1, 3, and 4. So 1 was just a vertical stretch by 2. 3 was a compression by 1/2 and 5 units up. And 4 was a compression of 1/3 and 2 units up. All right, so on the back side, page 16, we're going to write the equation as described. So again, a lot of this is kind of a review. We're just adding in some stretches and compressions. So if we have, for a stretch of 4, we want A to be 4. We also have a vertical reflection, so we want that to be a negative in front of the 4. And then 2 units to the left, so we want it to be minus 2. And no up or down. So we have a negative 4 in front, in parentheses, and x, and we go the opposite of our h, so plus 2. And then squared. I'm going to have you, let's do one more. We'll do one more together. Let's do number 4. So we have a vertical compression, so that's going to go for our A out front. And then we have it vertically reflected, so that's again negative. And no left and no right. So you can put 0 or cross it out. So all we're going to do is put the negative 1/2 in front of our x squared. So again, our parent function, we need to have x squared somewhere. Make sure that if something's going in the parentheses, then the squared is on the outside. So try 2 and 3 on your own. Check when you're ready. Compression out front, stretch out front, shifting up to behind. All right, the last section here, take a look at one together of writing it, and then you'll practice the rest on your own. So this one, it looks like we're going over 2, up 2. Instead of over 2, up 4, half as much as we normally would. So we want a 1/2 in front, and then an x squared since we're not moving left or right or reflecting. So it's just a compression by 1/2. Let's take a look at one of these down here. So over here, this one's a reflection, so we can go ahead and write reflection. We're also moving to the right 3, and we're moving up 8. So that means I need to have a negative out front, I need to have a plus 8 behind, and I need to have a minus 3 on the inside. So try those last 2 on your own, check when you're ready. Number 2 was a stretch by 2 since you're going up twice as much, so 2x squared. And the last one had a lot of things. Pause if you need a little more time to look at that. reflection, stretch, up, and left.